The technique which we're using is generally known as OSL dating, and OSL stands for Optically Stimulated Luminescence. And what it allows us to do is to date the last time mineral grains within the sediment have been exposed to daylight. We can date young sites, and this is one of the advantages of luminescence dating. We can date things which might only be 10, 20 years old, up to maybe 500,000 years, and we are looking at extending this age range to maybe 1 million. We can date things which have been exposed to daylight, and then as the grain becomes buried, it will absorb dose over time, and we can collect the sample in tubes. So this is one I collected earlier, and I've wrapped it up. And we have to make sure we shield it from light while we do the sample collection. So we're using black PVC tubing with rubber caps. So what happens is there's charge that builds up in these mineral grains over time, and this charge can be evicted by exposure to sunlight. And so basically at the time of deposition, that charge would be zero, so there'd be no charge at all. And then over time, the charge will be building up as a result of natural ionizing radiation from the sediment. So these are minute concentrations of uranium, thorium, potassium that are present everywhere within the environment. And we have to do a measurement of that. And so we need two things. We need to measure the amount of dose that's been building up in our mineral grains, and also we need a measurement of the radioactivity at the place where we collect the sample.